Okay, test. Good afternoon. Can someone respond if you can hear my voice?
Good afternoon, sir.
Okay, good. So, yesterday we discussed some of the questions. So today we're not going to discuss all questions because I believe all of you have done some questions. So we'll just maybe discuss just some questions then. So if you have any particular number you want to discuss, you have difficulty in which number so I can explain to you.
Number 3, sir.
Number 3. Let's see, number 3. Okay. I did not discuss this on yesterday's group. So after we discuss this, maybe you can share the answers with another group. Huh? Yesterday I discussed number 1. Yes, number 1, is it number 2? Oh no, number 1. Number 5 or 6. Number 5. Number 9. Number 10, I guess. Okay, so let's try number 3. Number 3, square coil, side 10 centimeters, having 100 turns. So this is the end, and rotated at 1200 round per minute, RPM. Okay, about an axis through the center and parallel with two sides in a uniform magnetic field of density 0.4 Tesla. So calculate A, frequency, B, root mean square, RMS, value of induced EMF, C, the instantaneous value of the induced EMF when the coil is at position 40 degree after passing maximum induced voltage. Okay. Okay, let's see A first. It's very simple in here. Right here. Okay. A, you can actually get it directly from this one. Yeah. Okay, from this one. What is frequency? Frequency, the unit is hertz or 1/second, right? Here can be how many cycles per second, how many, in this case, how many round per second, how many swing per second, okay? How many, for example, what else? How many rotation per second. So basically, the unit is 1/second, which is hertz. So in this case, it is state 1200 round per minute. So all we have to do is change the minute into second, right? So 100, 1,200 round per minute. Convert to the minute, convert to second. 1 minute equal to 60 seconds, right? So you have this become 20 then, 20 hertz. Okay. A. Don't mix with this one. 100 turns. 100 turns. This is N. Capital N. Okay. It doesn't say that turns per minute or per second. It's just turns. So it's different then. Okay. Okay. Now B. The root mean square value of the induced EMF. Induced EMF. So EM, if you check the slide, the formula for EM, check again at the slide, if I'm not mistaken, is 2 pi capital B, capital N, A, small n. Okay, 2 pi B, B is this one, 0.4, field of density. Capital N is 100 turns. How many turns? And then A, okay, A is this one, square here, A, right? And then what else? Okay, small n. If we check the slide later, small n is the frequency actually. Small n is this one. Okay. Okay, now 2 pi field of density 0.4 and 100 turns. How many turns? A. Okay, A now. A. How do you find A then? If set square cosine, this is 10, right? 10. So how do you find the A? A is area. How do you find N? Area is 10 times 10, right? Correct? Area. Up to centimeter square. But then remember the unit, you have to follow the international standard, which is meters. So convert this into meter square. So you have to multiply with, if you convert to meter square, multiply with what? 2, minus 2. Is it? I'm not sure myself. How do you, from centimeters to meter? Centimeter to meter. Yeah, correct. So, but this is square. 100. Let me check again. Square centimeter, square millimeter. Yes, correct. Correct. So this one is 100. N, small n is the frequency, 20 then. 20. So you get the value, but the question is asking for RMS value, root mean square. If you still remember the square, doesn't matter. For example, phi RMS equal to 0. V maximum, Vm, even I RMS. IM. So it's the same here. It's the same. So E RMS equal to 0. 0 EM equal to 1 multiply with this one, whatever the value of this one. Okay. Okay, now the C. Instantaneous value of the induced IMF when the coil is at precise 40 degree after passing its maximum induced voltage. Okay. Instantaneous. So if you check the formula, it is the maximum. So instantaneous, this one EM, E equal to EM sine, for example. Okay. But be careful with the degree, because it is stated that position 40 degree after passing its maximum induced voltage. After passing its maximum induced voltage. Sine. 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 Maximum voltage. maximum is in here, right? Maximum voltage, induced voltage. The degree here is pi over 2, right? Or 90 degree. Yeah. For sine wave, the maximum value is always 1, where the degree is 90 degree, pi over 2. So when it is stated that coil is at position 40 degree after passing its maximum induced value. So 40 plus 90 degree. So this one will be AM sine 130 degree. You have the EM here from this one value, whatever value of EM. Okay, just interrupt me if you have any question, or you can type in the chat room. Yeah. Okay, I'll give you other questions if you have still problem in which number. We set number 3. There's no response, meaning you can do all. No issue then. Okay, let me go to number 8. It's a short question but a bit tricky. Number 8. Check out number 8. 20K sine wave has a value of 50 volt, 85 microsecond. Determine Vm and sketch the waveform. You have to find the V maximum first and then sketch the waveform. Vm. Okay. The general equation for V is E equal to Vm sine omega t, right? Okay. This one, 20 is F, correct? Or you can expand sine 2 pi ft. Okay, 50 here is P, Pt. 5 is T. Okay, you have to find Vm then and sketch. Going to sketch first. This is sketch sine wave. This one, for example. So this is Vm maximum. Okay, this is T. 1 cycle. This is T. T. So you have to find Vm and T to sketch a complete waveform. Okay, so just insert each value then. F is Vt is 50, right? Vm is the one I'm looking for. 2 pi f, f is 20, 20k. T is 5 micron. 5 times 10 to the power of minus 6. Right. But please don't forget, when using your calculator, okay, this one you have to set into radian mode instead of degree mode. Instead of degree. Okay. Okay. Can you find this one first? Sine. What's the value of this one? Use your calculator. So next Vm equal to 50. Type the answer sine 2 pi 20 times 10 to the power of 3 times 5 times 10 to the power of minus 6. Set to radian mode. Not degree, yeah? Radian. I don't have my calculator here, so you can help me out. Pi 2 sine 2 times 5 times okay 0.5878. Okay. 0.5878. Okay, divide this 50 by 0. 50 divided by 0.5878. What do you get? Somewhere around 80 something. 85 now. Yeah, 85. So 85 round up. Fold. Okay. What about T? T is simply T equal to 1 over F, right? So F just now is 20K. 20K. So you want to convert to okay. Micro 6. This one is around. Okay, let me do this one first. Okay. 0.00005 second. Okay, or 50 microsecond. So sketch this one. In here, VM value is 85. T value is 50 microsecond. That will be for number 8. Number 8. Yes, number 8. So eh, last one. Yesterday I discussed on the phases. I want to discuss on phases. Yesterday number 5, number 6. Oh, yesterday number 5. Yes, so we discussed number 5 yesterday. So now I want to discuss on number 6. Okay. Read the question first. Understand the question first. Okay. Question is the instantaneous values of two alternating voltages are represented respectively by V1, 60 sine theta volt, and V2, 40 sine theta minus pi over 3 volt. By using phases diagram, derive the expression for the instantaneous value of the difference of this voltage. V3, V1 minus V2. Okay. You need to find the difference between V1 minus V2. If you are still recall our slide. Last time on phases, we combine V1 plus V2, but now we have to subtract V1 over V2. Pi over 3 is 45. 45. 180, yes, 45. Oh, 60, sorry, 60. Okay, now let's, in order for you to solve this, you have to sketch the faces. You have to sketch. V1, so no degree yet. No face. S like V2, 40 sine. Okay. We have to find V1 minus V2. Now, if you, let me use another V1, for example, this is V1. V1. 64. The degree is 0. Okay. Let's do V2. V2 is 40. But as the degree is pi over 3, pi over 3 is 60. If, so, or if, for example, in questions, this is plus, be careful if this is plus, not minus. So, the faces will be like this one, go up, this one, 60. Okay, V2, 40. But since this one is minus, okay, so it goes down of the x-axis, below x-axis. Okay, yeah? But then the question is V1 over V1 minus V2. V1 minus V2. V1 minus V2 is equal to V1 plus minus V2, right? Right? So if the green arrow is V2, so minus V2 is the opposite. The direction is the opposite. Is the opposite. Let me write this one then. So, okay, let's see if I can. Okay, this one. Is it? Yeah. So this is minus V2. Amplitude is equal 44. So if you do this, so this one will be the 60 degree. Okay, 60 degree. Okay. This is a sketch. We're not done yet. Okay. So where's the V3 then? The V3 is V1 minus V2 or V1 plus minus V2. So the resultance of the V3 is this one. If you took the test here, so V3 will be this one. This one is V3. We don't know the degree yet. I'm going to find out. This is V3 to V1 plus V2. Right, or equal to V1 minus V2. Yeah. Now we're going to find out the V3, V3, the amplitude and the degree. Okay, how? So we have to project. Okay, now since we have to delete this one because we don't need this one anymore, right? Okay. Yeah. So if the y-axis is this one. This y-axis. Okay. We have to project both V1 and minus V2 into x-axis and y-axis. Why is it? Why is it? Because we need to find the total component, either in horizontal or vertical component. Okay. Okay. For example, in horizontal component in x-axis, okay, we have V1. V1 is 60. V1 64. V2. Okay, look. V2. We need to project V2 in horizontal axis, x-axis. This one. We need to project into this one. The degree is 60, so that means the V2 equal to 40 cos 60. Okay, cos 60 equal to cos 60 is 1 over 5, 0.5 half. So this one will be minus 20. Don't forget minus because it's minus V2. So total component is total 60 minus 40. That means 60 minus 20 is 40. Direction is to the right. To the right. Because 60 is bigger than 20. Okay. Okay, now about the vertical component. V1. V1 is 0. Why is it 0? Look, this V1 is the blue one here. This is V1. If you project V1 into x-axis, into y-axis, the vertical is y-axis, project this one into y-axis here, into y-axis here, the degree is 90. The degree is 90. Cos 90 is 0, right? Cos 90 is 0, so 0 then. What about V2? V2. You project V2 into y-axis, this axis. Okay, you will get 40 sine 60 equal to sine 60 quadruple 2. Okay, say 34.64. So the total component is 34.60. It's going up to going up. Okay. Now, what about total value? Total value, you have y, you have x. Let me show you. You have V3 just now. This is V3. You have horizontal. This is horizontal. And you have vertical. Okay, vertical just now you get 34.64. As for the horizontal, you get 40. Right? So to find V3 using Pythagoras law, kan? Pythagoras. So V3 equal to 40 plus you get this one, V3. Okay. What about the degree? Degree here. Is the degree. You have y, you have x, you have vertical, you have horizontal. So use inverse tangent then. Inverse tangent, which is 34 point over 40. You get the degree then. Okay. So if you have to write down the equation later on, you can write V3 equal to this one. What do you get for this one just now? So for example, 40 squared, 36, for example, 52, okay, sine plus the degree, for example, 40. Okay, that's it. Because its degree is in the quadrant, first quadrant of plane XY, then so it's plus. Okay, that's number 6. Yeah, number 6. So you can ask the group for the rest of the number. We have discussed that. Okay. So let's see. Yeah. Yeah. Number 6 is similar with number 5. I have discussed number 5 yesterday. Yes, number 5. Yeah, number 5. I think the number is not that difficult. I think the one that takes more effort is on either number 5, number 6. The rest okay. So you can ask another group, or if you still have problem, you can ask me then. Okay. I don't see any question here. So I hope you understand. Okay. Because you're going to have a test by next week. Next week we also have a second tutorial before the test. So Tuesday and Thursday we'll have tutorial 2, and then Friday next week you're going to have test. Okay, if you don't have any questions, we'll stop here. Thank you. I'll see you next week then. Okay, bye.
Thank you, sir.
Okay.
Sir.